everyone. In this video, I am going to explain about subnetting. So first, we have to know about what is meant by subnetting. Network means here in the network we are connected more number of device. We can form a network here, computer device. So subnetting in the sense it is the process of dividing a single network into multiple smaller networks. So the entire network is divided into small networks. Why we go for subnetting means to minimizing the wastage of IP address. I'll explain how we can minimize the wastage of IP address in this video. So here this is one entire network, one router is there. So from this network these are all the small networks. So the smaller networks it needs 20 hosts for sales and 20 device for HR department and 15 hosts for management and 30 hosts for technical support. This is one simple example for subnetting. So small networks are there in the entire network. Why we say here we are minimizing the wastage of IP address means in general for class A 16 million hosts are available. That means it is possible to use 16 million address space in if you are using class A. So how we say it is 16 million means 2 to the power 24 bits. So I'll explain this first, then it is easy for you. So for class A, B, C, it may be any class in IPv4 address, the total address length is 32 bits that we know. So here, this is 32 bits. First octet, second octet, third octet, fourth octet. So for in each and every octet, 8 bits are there. So 4 into 8, it is 32 bits. In class J, the first byte that is considered as network bit and the remaining 3 bytes are considered as host bit. These 3 bytes that is the 24 bits are allocated to host, only the 8 bit is allocated to the network here. Similarly for class B, the first 16 bits are allocated to network and the remaining 16 bits are allocated to host bit. In class C, it is vice versa of class A. First 3 bytes are allocated to network. That means 24 bits are allocated to network and only 8 bits are allocated to host. So now we can understand for class A how many host bits are there and class B how many host bits are there and class C how many host bits are there. Similarly, how many network bits are assigned for class A, B and C. So class A 8 network bit 24 host bit, class B 16 network bit 16 host bit, and for class C 24 network bits and 8 host bit. So based on this only here we know how many hosts or addresses are available for each and every class. So for class A, the host bit here it is 24. So 2 to the power 24. Here H is nothing but the number of host bit available in class A. So number of host bit available in class A is 24. So 2 to the power 24 is equal to 16 million, nearly 16 million host or 16 million address space are allocated for class A. And for class B, the host bit is 16. So 2 to the power 16. So in 2 to the power 16, which is equal to 65,536 hosts are available for class B. That means that much systems are allocated or it is possible to allocate that much system in a network for class B. And for class C, only 8 bits are allocated for host bit. So 2 to the power 8 equal to 256 hosts. So 256 hosts are connected in class C. It is possible to use or connect devices in class C is 256. So this is basic. So from this, how we can No, the space are wasted in networking. Why we go for subnetting? So here, suppose if we are taking class C as example, class C range which starts from 192 to 223. So here the example is class C because it starts with 192. 192.168.1.0. So, for example, in a network, this is one network. 198.168.1 is the network. So, from this network, these are the subnets. So, 50 systems or 50 hosts are allocated for sales, and 50 hosts are allocated for accounts, and 50 hosts are allocated for HR, and 50 hosts are allocated for marketing. So in general, we are allocating. This is one simple example. So this is one subnet and this is one subnet. This is one network and this is one more network. So here in class C, we know the range. How many hosts are available? 256 hosts are available. So in for first network 198.168.1.0 256 is possible for class C. We starts from 0 here, so it is 255. Total 256 addresses are allocated for sales department. So out of this 256 systems, we are using only 50. We are allocating only 50. The remaining 206 address space are wasted here. Similarly, for account section, this is one more network. That's the reason 192.168.2.0 means this is one more subnet. So in this subnet, 0 to 255 is allocated for account. So out of this 256 system, 0 to 256, we are using only again 50 systems only. Remaining 206 spaces are wasted. Similarly for HR and marketing. So for each and every department, we are allocating 256 devices, but we use our need is only 50. The remaining 206 systems are 206 address space are wasted here in all the four departments. If we add all the four wasted spaces, the total here it is where wastage space is 824. Sorry, here I mentioned it as 820. So it is 824 spaces are wasted here. So 824 we use out of 256, 256, 256, 256. For 256, we wasted the address space is 824. We need only 200. For 200 address spaces, we waste this much space. So this is the problem occur in networking. Solution for this problem is the subnetting. So subnetting means whatever the system we need, that much system alone we can allocate to the department. So that is the concept of subnetting. Subnetting can be performed in two ways. One is FLSM and the second one is VLSM. FLSM means fixed length subnet mask and VLSM means variable length subnet mask. In fixed length subnet mask, for example, in our classroom, if you are taking a college or school means each and every classrooms are size of each and every classroom is same. So similarly here in FLSM, we are allocating the same size to each and every subnet. The address space of each and every subnets are equal here in FLSM. But in VLSM, again in FLSM, if you are allocating equal size to each and every subnet, the spaces are wasted here. So we can avoid that by using VLSM concept. So in VLSM, what is mean VLSM means, for example, in our home, the size of the room, hall, kitchen, so everything is different. Based upon our need, we are constructing the house. Similarly, here in VLSM, based on the need of that subnet, we are allocating the address space here. So this is the concept of FLSM and VLSM. When we FLSM, the address space is equal for all the subnets, but in VLSM, the address space is different for all the subnets. So I'll explain this in the problem. So in subnetting, actually in FLSM and VLSM, there are two types of addressing comes here: classful addressing and classless addressing. These are all discussed in the previous videos. So in classful addressing, the FLSM concept it comes. So the subnet mask may be vary, but the address space of each and every subnet is common. But in VLSM, the address space as well as the subnet mask is different for each and every subnet. It is comes under classless subnetting or classless addressing. So I'll explain this. So in subnetting, if we are converting the host bit into network bit, that means we are reducing the size of the host bit. So for class A, B, C, we know 8 bits for network bits and 24 bits for host bits in class A. In class B, 16 bits for network bits and 16 bits for host bit. And in class C, 24 bits for class C and 8 bits for class C. So in class C, by default, we are using these 24 bits as network bits and 8 bits as host bit. Suppose in subnetting concept, what we are doing means we convert the size of host bit into network bit. For example, here the host size is 8. We convert this into 6 means the remaining 2 bits are added in the network bit. So 24 becomes 26 here, 8 becomes 6 here. Suppose we convert the host size is 5 means remaining 3 bits are added to the network bit. Similarly, if we convert this 8 host bit into 2 host bit means remaining 6 bits are added in the network bit. So 24 becomes 30 here after adding 6 bits. So it is possible to change the that is the concept. In subnetting, we are converting the host bit into network bit. So in the example, you understand clearly. For example, 2 to the power 8. That means that time 256 address space are available in class C. If you reduce the host size into 6 means it becomes 64. The wastage, the space is reduced here. Now the host bit is reduced from 8 to 6 as well as the address space is also reduced here from 256 to 64. Suppose if we are reducing the host bit size from 6 to 4, again the size of the address is reduced here. Only 16 address space are used here. So the main concept of subnetting here it is converting the host bit into network bit, or we are reducing the size of the host bit to avoid the wastage of address space. This is the main concept. I'll explain this it in example in the upcoming videos.